go over a few things for tomorrow. So, you can skip this question. That you did the other day, and I'm gonna check tomorrow, and then if you have the expressions, I'll give you points. Right. For this one, simplify this expression. So let's take a look at that one. So the first thing, I want to do is identify the like term. So there is negative 5m here, and there's a negative 24m here. Those two are like terms, so I'm going to put them next to each other. And then negative 12 and plus 9, again, next to each other. So if it helps, circle them, use colors, right? Pretend they're written on rocks and you're moving the rocks, but make sure when you move them, you move the number with the sign that comes right before it. So now you can combine like terms. Negative 5 and negative 24 will give you negative 29. You'll have a calculator tomorrow. And negative 12 plus 9 is negative 3. So this original expression simplified, right? When you combine like terms, it becomes negative 29 minus 3. Same thing here. If you want to put a 1 here, you can. If you want to put a 1 here, you can. And let's identify the like terms. So 12k, yeah, there is one right here. Let me put them side by side, 12k and minus 1k, so they're like terms. A, there's a negative 1a here, and there's a negative 9a here. So I'll put them side by side. And lastly, the plus 5 at the end. Notice that the plus 5 is one term. There's no other terms. That's not going to combine with anyone. So final answer, if you combine these two, it's just 12 minus 1, or 11k. This is negative 1 minus 9. Be very careful. It's negative 10a, and then the plus 5. Okay, so that, again, is a simplified version of the original expression. What's an equation? An equation is two expressions that are set to equal each other. Right? And obviously, equation equal sign. So it has to have an equal sign. So an example, 5 equals 3x plus 2. That's an equation. 2 equals 2. That's an equation. Okay, it has to have an equal sign. It has to have an expression on the left side that says it's equal to the expression on the right side. Whether it's true or not, that's a different story, but that's what it's. It's a non-example. So this is not an equation. It's just a number 5. It's a numerical expression. This 2m minus 5, also not an equation. It's an expression, an algebraic expression, which I'll explain here at the bottom, but not an equation. So what is an expression? An expression is, right, it could be a numerical. So how do I define this? Are numbers or variables? And variables, right? Hang on. Which it's so numbers and or variables, right? That have operations between them. Right, so an example of a numerical expression, 3 plus 5. It's an expression, two terms, and it has 3 plus 5. Another example, 28 minus 12 minus 15 is another example of a numerical expression. Now, algebraic expression, algebraic expression has variables. So, an example, 4k plus 2, that's an algebraic expression. K, another algebraic expression. Okay, and notice that none of these four have an equal sign, which does not make it an equation. So, a non-example of something that's not an expression would be this: 3g minus 2 equals 8. That's not an expression, it is an equation. How do we know that? Because it has the equal sign. we're saying here that's 3 multiplied by a number and then subtract 2 equals 8. So what is the value of g? And that's what we have to find in this, the value of g to make that equation, to make the expression on the left side equals the expression on the right side. So that would be a non-example of an expression. All right, let's identify things. So here's an expression, 5m. So this, first of all, this is an expression, algebraic expression. The 5 is called a coefficient. The m is a variable. This -2 is also a coefficient. The k is another variable. And the 3 right here is a constant, because that 3 will always be a 3. This is an equation. And in this equation, the 12 is a constant. The -28 is another constant. The m here would be a variable. And the 2 would be a coefficient. Okay? So make sure you know the parts. Two-step equations. Well, I have a number that I'm thinking of called m. It's being multiplied by 8. So let me write that over here like this. I am thinking of a number. I'm multiplying by 8. I'm subtracting 15, and that equals 1. So notice that whatever is written here, I just wrote it this way. Same exact thing. Now, to find the value of m, right, what number multiplied by 8 subtract 15 equals 1, to find that, I'm going to use inverse operations. And the two inverse operations I'm going to use is, well, first of all, I'm going to add 15 to both sides and then divide both sides by 8. So if you follow this, you can't really get it wrong. First thing it says, add 15 here. So the reason I add 15 because a -15 and a +15 will equal to 0. So I want that 15 to go away. Remember, our objective is to isolate our variable. So this original equation, the 15 is going to go away, the 8 is going to go away, and all we're going to have left is the m on the left side. So we're working towards that goal. So the -15 and 15 goes away. So already our equation got much smaller. Sorry, I forgot to add 15 on this side. So remember, whatever you do to the left, you do to the right. So 1 plus 15 is 16. So I just did this step. Second step says divide by 8. So I'm going to take this, divide by 8, and take this, divide by 8. 8 divided by 8 is 1. 1 times m is 1m. You can write 1m if you like, but we don't really need it. And then 16 divided by 8 is 2. So that number that will make this equation true, apparently, is 2. So here's my original equation. And instead of the m, which goes right here, I'm going to write 2. That's the solution, the value I found. And that's the value that makes this equation supposedly true. 8 times 2 is 16. Minus 15 equals 1. 16 minus 15 is 1. And notice that the left side is exactly equal to the right side. So our solution of 2 makes this equation true. So yeah, that's your basic, right? Two-step equation. Now, here is a question that you may have, and multiple choice, so I'm not asking you to show work. But like we discussed in class, what's one quick way of finding, of solving this? Well, you can solve it, if you like. Go ahead and do the distributive property, combine like terms, and everything else. Or because it's a multiple choice, and you are given one of the three is the answer, you can just plug it in. So what I mean by plug in, so let's take the first one, 3, 1, 3 parentheses, 1 minus, and I'm going to put a 0 in here. So wherever I see the x, I'm going to replace it with 0 and see if it works. Equals 2 minus 4 times 0 plus 7. So now I can just figure this out. 3 times 0 is 0, right? So this becomes 0. 1 minus 0 is 1, and then 3 times 1 is just 3. So on the left side is equal to 3. On the right side, -4 times 0 is 0, so that's going to go away. I'm left with 7. And 2 times 7 is 14. Is that true? No, it's not. So 0 is not my answer. And that's what you would do, right? I don't know if it's the easier way or not. Or like I said, you can still solve it. So I'm going to try 4. 3, parentheses 1 times 3 times 4. So everywhere I see the x, I replace it with 4. Equals 2 minus 4 times 4 plus 7. So they're saying that 4 is a solution to my equation, which means that if I replace the x with 4, it makes the left side equals the right side. Let's see if that's true. 1 minus 3 times 4, so that's literally 1 minus 12, which is negative 11. And negative 11 times 3 is negative 33. So on the left side, I'm left with that. On the right side, negative 4 times 4, sorry, it's negative 16. Negative 16 plus 7 is going to give me negative 9. And negative 9 times 2 is going to give me negative 18. Is that true? Also not true. So 4 is not the solution to my equation. And eventually you're going to do 11. And if you do 11, hopefully, and I'm not going to do it, but you can plug in. So 3, well, I'll do it. 3 times, and now let me put negative 11. So I'm replacing every x with negative 11. And hopefully that is truly the answer. So let's see, here we got 33 plus 1 is 34. So we got 34 inside the parentheses, and you can use a calculator. And on the left side, we get that, let's see, 12, we get 102. On the left side, if I substitute x with negative 11, I get 102. Hopefully I get 102 on this side. So we got 2. Negative 4 times negative 11 is 44. 44 plus 7 is 51. And 2 times 51 is 102c. So negative 11 makes this equation true. By substituting negative 11 into, for x, it makes the left expression equal the right expression. So, and I don't know if that's better than, and again, you could have just solved that equation. You can pull the equation to the left and solve it and get the answer. You have a choice at least. Okay, so these equations, this one, and this one, they are pretty much where you're going to see tomorrow. So the first equation, 1, distributed property. No, I don't see any parentheses, so I don't have to distribute property. 2, combine like terms. Look at the left side. Can I combine negative 8 and 3b? Yes, I can. I can combine these two. And that gives me negative 5b. On the right side, can I subtract 8 minus 6b? I cannot, so I just copy that down. 3, is there check for variables on the left side and the right side? And there is. There's a negative 5b and a negative 6b. One of them have to go. And we talked about this. We said that the smaller one will go. And the smaller one between negative 5 and negative 6, think about a number line. If that's 0 and this is negative 5, negative 6 is here. So whose smaller one is the number that is further to the left, which in this case is negative 6. So that's what we're going to get rid of. When I say get rid of, what do I mean by that? So how do I get, what can I do to negative 6? Negative 6 plus something or minus something equals 0. Well, in this case, the additive inverse of negative 6b would be plus 6b. And notice that if I combine these two, it gives me 0, which is what I want, right? So that is going to go away. I'm going to take that 0 because I don't need it, but I'm going to bring the 8 down. And over here, let me do plus 6b as well, right? Because if I add 6b to this side, I have to add 6b to the left side. And negative 5 plus 6 is just b, or 1b. And that's it for this particular problem. That's it. There are no more steps to do. So now I would go back to the original equation, and everywhere I see a b, I would plug in 8 and make sure that it works. So negative 8 times 8 plus 3 times 8 equals 8 minus 6 times 8. Let's do, doesn't matter which side, let's do the left side. So here we get 8 minus 6 times 8, or 8 minus 48. And 8 minus 48 is negative 40. So the right side is equal to negative 40. The left side, 8 times 8, negative 8 times 8 is negative 64. Plus positive 3 and 8 is 24. I combine these two, I get negative 40. So my solution b equals 8 is correct because it made the left side equals the right side as we just checked here. Okay, the other problem here, we're going to check for distributed property. None. Number 2, combine like terms. Can I combine anything? Look here, let me make a wall. Negative 8 and negative 2v, I cannot combine, so that stays as it is. On the right side, this guy here and this guy here are like terms. I can combine those two. So let's forget the variable for a second. What's negative 7 minus 7? That would be negative 14v. And then plus 16. There's nothing else to combine, so I move on to the third step. Variables. Check if there's a variable on the left and a variable on the right. And there is. On the left side, I have negative 2v, and on the right side, I have negative 14. So again, here's my number line, here's 0, here's -2, and here's -14. Who is further left? -14. So I suggest get rid of that. To make that equal to 0 here, what do I add or subtract? Well, I'm going to add, in this case, plus 14v. And if you notice, -14 plus 14 gives me 0. And if I add 14v on this side, I will add 14v on the other side. So this will go away. It becomes 0, which I'm going to erase. The only thing left over on the right side is 16. So I'm going to write 16. Over here, -8 combines with no one. And -2v plus 14v is positive 12. Now, I will continue to do this for a little while more. I have a variable v that's being multiplied to 12. Oh, hang on. I hope my battery doesn't die. Don't die, don't die. Okay, saved. I have a variable or a number that I don't know called v, which is being multiplied by 12, and then subtract 8 gives me 16. So everything that you see here horizontally, I wrote here vertically. So going back was our strategy, going backwards, right? We're going to do the inverse operations of these two. So we're going to add 8 first and then divide by 12 to get our value for v. So first thing, add 8 over here, add 8 over here. Remember, our goal is to have v by itself here, right? So to have v by itself, I have to get rid of the -8 and I have to get rid of the 12. So first we get rid of the -8, gone. 12v comes down. And then 16 plus 8 is 24. Step 1 did. Step 2, divide both sides by 12. Divide that by 12, divide that by 12. 12 divided by 12 is 1, and 1 times v is just v, which is what we wanted, and 24 divided by 12 is 2. There we go. Now, you got to do the check and make sure that is true. So everywhere I see the v, I'm going to replace it with the number 2. So 8 minus 2 times 2 equals -7 times 2 minus -7 times 2 plus 16. You can put that in your calculator. 8 minus 2 times 2 is just 8 minus 4, which is going to give me 4. So on the left side I get 4. Hopefully on the right side we get 4 as well. -7 minus 2 is -14. -7 times 2 is -14 again, and then plus 16. Did I miss something? Hang on, sorry, this is the negative. That was my mistake, so let me change that. So this should be -12. On this side, I get -28 plus 16. -28 plus 16 is indeed -12, which equals to -12. So again, v equals 2 was the right answer. It's the one number that I can replace the v with and make the left equation, the expression equals the right expression. Okay. Last problem finally has some distributive property. So step 1, take care of the distributive property. So 7x minus 14 doesn't do anything. And then we multiply these two and these two. 7 and 5 is 35x, they're both positive. 7 times -6 is -42. So distributive property gone, which makes my parentheses go away. Number 2, combine like terms. So look here. Can I combine these two? No. Can I combine these two? No. They're not like terms. So let's go to step 3, check for variables. There is a variable on the left side and there is a variable on the right side. Get rid of the smaller one. They're both positive. So if you compare 7 to 35, obviously 7 is the smaller one, so that's who we're going to get rid of. That's a positive 7x, so we're going to do minus 7x. And on the other side, I have to do minus 7x as well. So notice that these two go away. -14 comes down. 35 minus 7 is 28x minus 42. And now you know what to do. So again, our equation is going to look like this. Our final line is going to look like that. In order to do that, I got to get rid of the 28 and the -42. So we have a variable called x, which is being multiplied by 28, and then subtract 42. And he gave us -14. So going backwards, I'm going to do plus 42 and then divide both sides by 28. So let's see how that works. So step 1, line in the middle. We're going to do plus 42 here, which means I add 42 here. These two go away, right? It becomes 0. 28x comes down. Negative 14 and 42 is positive 28. Now I divide, right here I am right now. Divide this by 28, divide this by 28. Simplify to 1, and then here it also simplifies to 1. So it's telling me that x equals 1. That's beautiful because x equals 1 makes life so much easier. So 7 times 1 minus 14 on the left side. On the right side, 7 parentheses 5 times 1 minus 6. Are they equal to each other? Hopefully. Let's do the left side. 7 times 1 is 7 minus 14. I get negative 7. On the right side, 7 times parentheses, what is that? 5 times 1 is 5, minus 1, minus 6 is negative 1. And 7 times negative 1 is negative 7. So the left side does equal the right side. And that's it. Okay, that's your little review.